My name is Simon, and in this session we'll go through the components and how AiQu works. So, I've pre-drawn a little diagram here that I'll fill out and discuss the components with you. So in this top layer that we'll go through first, we call the access layer. So access, the access layer. In this access layer we have a few different components. We have a client CLI. This CLI tool will be a binary that you can install on your local PC. This binary will be the same kind of syntax that will be used on different systems within the cluster. So it's a utility for you to use the same kind of syntax on your local PC as in the rest of the environment if you would like that. The next bubble is a web client or web GUI. Web GUI. This web GUI will be the main point of contact for a lot of people. So it will contain a few different modules and will handle most of the works. So a few submodules within the web GUI is first the REST client. REST client. This REST client will talk natively to our REST server, as everything in the system is REST-based. So all the communication is through our REST server. The middle part here is our Container Connect. We shorten it by CC. So the Container Connect module is something that allows you to connect directly to your running container within the actual host system below here. And then as the last option here, we have a web CLI. So this is essentially the same CLI tool that's available here, but in a web shell. And the last part is a straight SSH connection that will pull you through to a terminal server within the system that allow you to, again, use the same kind of syntax within the client CLI and web CLI. Going down one step, we end up in the AiQu core layer. So this is the core layer. The first module we'll talk about here is the REST module, very integral part. So this REST module will handle all the communication with the different clients. It's the input and output to all the client utilities. Next one here is the agent module. The agent module connects to the client connect or container connect module and then talks down to your actual containers. So this manages the running containers that you're able to connect to. Then one step over, we have the TS module. So this is the terminal server that you essentially will connect to from the SSH channel. Then one step down again, we have the auth module. The auth module will authenticate all the steps within the entire system. So the first thing you will often do is through the REST authenticate your user, you get a token back and you're authenticated. One good thing about the auth module is that it also enables you to use external auth. So we can do external authentication. Auth, be it Active Directory, LDAP, or many other options. Next thing from here, we have the actual master node. The master node is responsible for sending jobs from the queue into the actual nodes. So it handles a lot of communication within the system as well. Next over from that node, we have the database. And the database will store all the operations before they executed and keep track of a lot of data, general database utilities. Next over from there, we have the registry module. The registry module is a module designed to allow us for local handling of Docker container registries. So once you upload or download a container to our system, it will be residing in the registry node and then pulled down to the actual nodes when required. Then down from that, we have our meta node. The meta node is a metadata collector. It'll connect down to your actual nodes, and all the nodes will send up data to the meta collector and store that and use. It also feeds the web GUI with data for graphing and general understanding. And then we have 2 boxes left, and these 2 boxes can actually be expanded into many more, and they're what we call realm controllers. Realm controller. So let's call this one X, and we'll realm controller again. Controller. Let's call this one Y. So these 2 realm controllers handle 1 realm each. And the realms I'll go through just shortly, but just note that these can expand, and minimum 1 and maximum many. So then we go down a layer more, we end up in the realm layer. So this realm layer is where the actual nodes and data resides. So in the realm layer we have the actual compute nodes. So let's say for this example this is a DGX. We have 2 DGXs. Well, let's say we have many GGXs, so can be as many as you would like. DGX. With that node management or node handling, we usually also have some data that's interconnected between all the nodes. So we have some kind of shared data set or data platform, and this can be any number of different mount points. What's generally considered is that all the data down here is mounted on each or most of the node at least. So this is realm X. Realm X. And over here we have realm Y. And again, same thing. We have compute nodes, DGXs, could actually be a general GPU node. So anything that will accept the jobs from the scheduler could absolutely even be a straight up CPU node. So this could be without any GPU attachment available as well. But then again, most systems will absolutely have some kind of shared storage, because these are generally considered a cluster, and they want to share the storage so they can read and do the same operations. All right, so this concludes the general layout and the building blocks of the AiQu software stack.